if you guys don't mind. Yeah.
Sorry.
Thanks. I'm going to be talking about immersion optimized IT platforms, immersion optimization for IT equipment, enterprise platforms, and everything that we do around this topic with Asperitas, and a lot of that, a lot of the things that we do, we also do within OCP, within the Immersion group of ACS. Now, before I get into the actual IT side of things, just for the people who are still unfamiliar with our technology, we have a booth downstairs where we have a system live, where we can demonstrate this technology. I won't spend too much time on the technology introduction, since I see a lot of familiar faces anyway, and there's other presentations that you can look up on the OCP website as well on this. One thing that is new is that we'll be launching soon a 21-inch version of a system. And our technology is unique in a way that we are using passive immersion technology. So we are relying on natural convection with single-phase liquids. And not just any liquids. We're using hydrocarbons, technically oil. And with our developments, we've also been able to drastically increase the power densities that we can support. So without changing the oil, without changing the technology, and this may sound odd, but it all comes down to the way that we position our data or specifications, because we only use data that we have actually been able to validate and that we've been able to prove. And we've been able to increase our power densities to approximately 43 kilowatts. Especially with the upcoming 21-inch system that is going to be higher in power capacity. Some of you may be aware, and if you're not, here's the news. Recently there was a press release about the investment that Shell did in Asperitas. That is on one side related to liquids development, which we're doing together with Shell, and on the other hand also related to new energies, which my colleague Wim will be presenting on this afternoon, so I strongly recommend going into that session as well. But the reason why I think it's valuable to mention this is that we, together with Shell, we're looking at optimizing liquids for this purpose as well, which will allow us to eventually, on our roadmap, keep on going with increasing these power densities. And the good news is that's not just for Asperitas. This is for the entire market. So the liquids, Shell is a large global provider, and these liquids will be available for the entire industry. Now on our technology, a lot of our technology is focused on integration of elements that are needed for high availability of IT equipment. That means our technology is equipped with full electrical integration, rack level switchgear, power distribution. The cooling infrastructure is integrated, including all the thermal management and safety features. Everything is focused on containment with dual hull, level management or level monitoring of the liquid levels, cable management, thermal serviceability, IoT optimization. Everything is part of the offering that Asperitas has positioned in the market. And this is something that we take seriously. For us, this is an important thing. We've done a lot of research in the past on what are limitations, what are challenges when you want to adopt liquid cooling or immersion cooling in this case. And these are drivers behind our technology development. Another factor that we are very highly focused on is the optimization of infrastructures within data centers, and the level of safety that can be applied. And all the features for this are built into the technology and can be utilized in any way that it's required. So if there is a requirement for thermal optimization, as in maximizing the temperature output of a system, which is a very relevant value if you're considering heat reuse. The higher the temperature, the more value you are creating. And that is something that the system can automatically and fully autonomously can manage and control. And if it's all about keeping the lowest possible temperatures, which is a completely different perspective or a different way of working with cooling infrastructures and optimization, then that's also something that the system can autonomously manage. So we are very active as well in the public domain, in the industry platforms. We're lining up, we're contributing and talking in the ASHRAE calls, we're active in OCP, and we do all this with a lot of, well, first, of course, with a lot of passion, but also with a lot of interest in maturing the industry and creating a larger industry and increasing the adoption rate. And part of that strategy is also about, to investigate, to develop entirely new concepts that come up when you start looking at immersion. So liquid cooling is one thing. Immersion is a subdivision of liquid cooling, and it has some very unique properties which are in essence very interesting, or at least worth consideration for a lot of customer deployments, for a lot of data center environments. One of these things is temperature chaining, which is basically fundamentally an energy cascade. This morning, in the earlier presentation, we were looking at the rear coolers. Just now, we were looking at cold plate. We're talking about immersion right now. And all these technologies can actually operate in synergy within the same data center environment. Actually, there is a lot of value in combining the technologies in a data center environment. An energy cascade can be created by, for example, using the thermal output of a rear-cooled rack, of the rear cooler, rear heat exchanger, and using that as an input temperature, as an input supply for a cold plate solution or an immersion system. And by doing so, you're actually increasing the temperature difference across your entire water circuit, which, especially when everything is focused on free cooling capabilities, or perhaps adiabatic cooling, you can drastically increase the efficiency of the entire cooling setup. But another fundamental thing, the temperature chaining and energy cascade is something that we've been talking about for a few years already. But the dielectric ride-through is something that is being discussed today. And ride-through, the term ride-through is not as well spread, not very spread around yet. And I'd like to go a little bit into that in the next slide as well. Ride-through actually is the effect that when a chiller installation or a cooling installation fails, that a technology can still work for a while based on the buffer that liquid may offer. If a pump fails with a cold plate solution, there is only a very small amount of liquid that you can access for this effect. But with an immersion system, if a pump fails, there is still a bath full of liquid, which can be a buffer to keep on capturing thermal energy from the IT equipment and allow a longer lifetime, a longer operating time. And these actually can be factored into a facility design or a platform design, which, especially when it comes to high availability implementations, can be of tremendous value. I'll get back to that point on the next slide with an example as well. But a lot of the principles behind liquid cooling that are quite new to the industry are already being put into practice. A live example in the UK, for example, is CoolDC. They have literally built everything around specifically for liquid. They're able to redirect liquid infrastructures and reorganize the way that liquid is distributed through the facility through different type of cooling setups. BytesNet is currently working on a new layout for the facility based on these kind of principles as well. And the Asperitas Lagerweide project, which my colleague Wim will be presenting this afternoon, actually maximizes the benefits of such an approach by creating full synergy. And that means the energy that goes in comes out as heat with almost without losses. Now, as promised, the write-through, an example of write-through in this case. This is something that we shared within the TC909 group for the announced white paper for the impact of liquid in the data center industry. And what this illustrates, this was an actual scenario that ran in our facility. After a chiller failure, in our facility we have a lot of different server systems with very different specs running together in one immersion system that we use for R&D purposes. And at the point in time we had some limitations set on our system which exceeded the specifications of a few servers, which actually provided us with a very interesting analysis after that chiller failure. What you're looking at here on the left is a table that gives a very small description of what type of servers were inserted at the point in time. The overall power load was slightly over 10 kilowatts at the time. Not a crazy load, but it's decent, right? And the cooling supply, as you can see here, the first red dot is slightly above 40 degrees Celsius. For us, that is the normal operating temperature. It's a temperature that we start all validations on. What you can see here is a chiller failure at time point 0. And what happened to the system after that? Now I have to explain, there's a very small water circuit that keeps on circulating, which we would call a facility write-through, because that is a water circuit that still keeps pumping, but the liquid in the water circuit then becomes a small buffer as well. That buffer is relatively small, and that can be seen as well by the rising line. So the red line is the water return temperature, the blue line is the water input temperature. So what you notice is that at the very first stage, after about approximately 15 minutes, the water input temperature has reached the same temperature as the output temperature was at the starting point. But if you look at the actual oil temperature, the gray line is the oil temperature in the bottom of the tank, and the yellow line is the oil temperature in the top of the tank. What you're seeing is that those lines take some time to adjust to this new cooling environment. Essentially, at some point, after that 15 minutes, the water circuit has stopped being a cooling mechanism, a cooling supply. So the facility write-through in this example, you could state that that was about 15 minutes. The very first system that failed was at around approximately on the 20-minute mark, and that was a 12 GPU system that has a temperature tolerance of 36 degrees Celsius cooling supply. So technically, during the start of this scenario, the environment was already too hot for that system. So that system has failed when the cooling temperature when the cooling temperature reached 50 degrees Celsius, approximately. Is that correct? Yeah. That's when it started failing. Well, it's not a full failure. It's just it throttled down. It stopped working with its GPUs. It did a couple of reboot cycles after that, which you can see a bit further on at around the half-hour mark. It did a reboot cycle, the power dropped, power increased, it tried to ramp up its GPUs, but it failed. And then it kept idling and eventually failing. But if you look at the overall system, it's approximately 50 minutes. Some of the Intel CPUs that we were validating in the system started throttling down. Basically what it did is it got out of turbo mode. With superior cooling technologies, CPUs usually run into turbo continuously. It happens automatically. So these CPUs started running into their maximum tolerances. And eventually what happens is that if you look at the top marks here, this is what our system does is send out automatic alert. There's different levels of alerting, and if you ignore alerts long enough, eventually it will escalate into a critical failure, and that's when the system will start will engage the safety mechanisms which are designed to protect the IT equipment. And what you can see in this example is that at 1 hour and approximately 10 minutes, these safety systems have been engaged. So the actual write-through event in this case, with a system that was already running above its thermal spec for the IT that is sitting within, was actually approximately 1 hour and 10 minutes before the automatic safety features engaged. But no real server, the servers have not been damaged, the servers have not switched themselves off, the CPUs have not triggered a shutdown of a system. So everything has been within operating parameters, above the operating parameters, but not above critical parameters throughout the entire event. Now, this is something that we can actually calculate and design into an IT platform. So a high availability solution can actually be designed for a dielectric write-through. In the case of immersion, the buffer capabilities of the immersion liquid is something that can be factored in. Now, onto the IT platform design, and this content is also currently part of the contributions into the IT Gear white paper, which is announced for the next global summit. And this is a view on what should be done to ensure a long lifetime of IT equipment. I will end this with a couple of concepts that we have developed. And that we are developing and evaluating together with our manufacturing partners. And the basis of this is that you cannot assume that every IT will always be compatible with liquid. And this is something where there is a lot of confusion about in the industry. In order to make it easier for the market to adopt immersion technology, there are different ways of presenting information. You can never assume that an IT configuration will be fully compatible with liquid until you've actually tested it. It's not rocket science, it's not difficult, it's also not very scary, to be honest. It's just a little bit of homework that needs to be done before any system can be qualified as immersion ready. Another aspect of our design angle is that thermal optimization will increase the lifetime of the IT for very simple reasons. It's relevant for liquid flow to make sure that liquid flows in a predictable manner, which will reduce failures based on material compatibility, based on thermal properties, thermal capabilities, and electrical safety. And which will eventually deliver a system which suffers less from thermal shock. If you design something thermally well, the very fast temperature fluctuations that we're used to in air environments are drastically reduced. And if you design it well, it actually opens the door to a whole new range of possibilities. Now, yesterday morning during the opening notes, there were a lot of references to Moore's law, how that's declining, how that's slowing down. Some people argue that it's already invalidated. It doesn't exist anymore. Some people claim it's still there. Well, if anything, at the very least, whatever is there in Moore's law, and if we want to maintain that line, that gradient, it has to be done in other ways than just adding the amount of transistors per square millimeter, or so the density on the chip. With liquid, we can actually do this. So one of the examples of the things that we've been doing in terms of evaluating possibilities is that we've been running one of the AMD EPIC chips. We've run them stable at 318 watts, which is twice the amount of power that they've been designed for. And we've been able to do that stable with 40 degrees Celsius cooling and with tolerance, with a lot of temperature tolerance left. So the limitation was not the cooling capability, the limitation was the stability of the CPU and everything around it. And this is something that you can actually start designing for. Another thing that we work with is optimized immersion chassis, which are chassis that are fully designed for optimized liquid flow, and which can actually tackle a couple of challenges related to immersion technology. I'm noting the time, so I need to rush a little bit. During a certification process or a validation process for immersion, there's a couple of steps that we undertake, which is, and the first step is simply paperwork, just to establish viability for immersion of a system. And we create a test build, we create prototypes together with manufacturers. This is something that we do together with the manufacturers. We work with engineering samples that we receive from manufacturers. Very often, sadly, the work is also covered under NDA. For us, that is not a problem, because the aim for us is to help the IT manufacturers in designing for liquid. This is not a job that we should be doing. Right, so this is something that we do along the way to make sure that the manufacturers will be able to do it. And eventually, for a full certification process, we do a long-term duration test as well. And long-term, in our terminology, means 3 months, or 2.5 months to be precise, 10 weeks, in which we evaluate the system. So there's a lot of things that we do in this. The system undergoes some very, very tough processes, both mechanical and thermal. The system overheats. We completely disassemble and reassemble the systems. We usually filter out problems that actually relate to the original manufacturer and may have nothing to do with immersion. We very often notice some of those as well in this process, which is an indication of how strict this process is. Now, we're doing this work also together with some of the OCP members, for OCP partners within OCP. And with those, we are aiming at some pretty disruptive new ways of designing IT, and a lot of non-disruptive stuff. So first of all, we already have developed a high-density CPU environment based on both Intel and AMD CPUs. With the largest system that we're developing, we're looking at adding additional capacity for 24 more nodes with a minimal physical expansion of the system. With GPU systems, we've already done installations with very high quantities of GPUs. But especially when it comes to AI, we're looking at 48 nodes systems with 192 NVIDIA GPUs. Obviously, we're mostly looking at the higher power rating. One of the latest developments that we're looking at is NVM storage. Currently, the solutions that we have are very basic, based on air design systems that we've re-engineered and that we've optimized for liquid together with the manufacturers. But we also do make a lot of design concepts, as in, okay, so what if you were to design these type of technologies for immersion specifically? One of these concepts we come up at around 2,000 NVMs, which results in 40 kilowatts of NVM storage, which is quite impressive to achieve with NVMs, because they are very good on, very efficient on power. But these type of platforms will make a lot of difference in how far you can go with integration of different workloads. And we're doing all these, as mentioned, we're doing all these developments together with our partners. Either they sponsor, or they supply, or they work closely together with us. I cannot always elaborate on these type of partnerships. Some of them I can, and the ones that what I can say is on here. So we've been working with 10G Tech and Leone. Leone is a company that we've mentioned several times as well in previous events on optimizing for immersible optical cabling. It's one of the limitations with immersion technology that optical cabling is not very suitable to immerse. We're working on immersion liquids together with Shell to optimize those and to increase the barrier, to get past the current density figures and to increase those and to get to the next level as well. And we're working with IT equipment providers here within OCP with WeWin and Dell and Penguin, and Supermicro is also one of our partners. There's more, but with more strict NDAs applied. We're working on this storage angle together with an undisclosed partner. But we're looking for more and more partners to work with on these platforms. There is a lot to be gained when you're developing for immersion. But to access this, we need to work together with manufacturers who can take on these efforts. Right? CPU evaluations we do with the materials that we receive from the CPU manufacturers. Some CPU vendors are actually partnering with us on these kind of things. So the point is, in order to get these liquid technologies to a new level, we need to make sure that the IT equipment is going to be able to benefit from the new capabilities of embracing liquid. And that's what we're starting to do within ACS. Together, so far together with Steve Mills, but he's moving up the chain to the incubation committee, I learned. Sad to see you go. Well, you're still there, but we're looking for partners that are willing to take the next step and make sure that these platforms are going to be developed properly. We're not an IT manufacturer, we're not an IT developer, we're not even an IT trader. We don't sell IT, we don't trade in it. So all this work we aim to hand over to our partners, right? So if you want to work with us on these and use the technology that we can jointly develop to bring it, by bringing it into OCP, contact us, come and work with us on these. And every third Tuesday of the month, we're having the OCP immersion call for the community call. So join that, please join that. Join the cold plate solutions as well. Join the rear dock talks as well, and help us all get OCP to this new liquid level. That's thank you.